So yeah, as I'm talking about deep research is an AI agent. What deep research does is that deep research, let's say if you ask any question to this AI agent, it will not give us the answer directly. Instead of giving the answer, what it does is that it will ask follow-up questions actually, follow-up questions related to our question. And then uh, after taking the follow-up, let's say if I ask to recommend a nice restaurant in one place, it will ask follow-up questions like what is your budget range? It will ask some questions like how many people are you planning to have in a room? So it will ask some follow-up questions related to our question actually. So what just like human, what it does is that first it asks follow-up questions. Once after asking follow-up questions, what it does is that it will go to entire internet. It will search for all the links that are available in the internet. It will gather the content. Once after gathering the content, it will give us a report like this. It will give a detailed report, and then it also gives some visualization stuff actually. So this is a very good website, and the major difference between 4O and deep research is 4O. You'll get answers very quickly. I mean, let's say if you ask any question, you'll get answer in seconds, right? But deep research will take time. I mean, if you ask any question to deep research, it might take 30 minutes or it might take 24 hours to give the answer because it is searching an entire internet and then getting most accurate information. So the time bound for for your questions might vary actually. So deep research might answer questions in 2 minutes, or 20 minutes, or 24 hours. It depends on your question actually. So this is a very good step moving forward into our AGI. And then there was a humanity test actually. Humanity test is to check how closely the LLMs are generating with respect to humans actually. So in this humanity test, the DeepSeek is only giving us 9.4 accuracy, which means that only 9%. Let's say if DeepSeek generates some answer, only 9% of the entire answer is closely related to human. Whenever a human is writing something, there will be human consensus, right? But the OpenAI's the deep research, it is giving answers close to human actually. Whatever human is writing, the deep research OpenAI model is giving answers which are close to human, which is 26. But they here mention it at 26, but in Twitter, Sam Altman, CEO of OpenAI, he said that it is close to 35% or something like that. So yeah, as I said earlier, we are moving ahead of AGI. We are getting very close to AGI. These are the two agents. In last week, they have released Operator. Operator is one agent where you can order everything, where it has an interface, UI interface, and then you can order anything from Operator. Actually, you can perform all the web operations using Operator, and then deep research is also a good innovation where it does so much of research actually. In backend, it is doing more research. So yeah, this is one good thing in AI world. As I said, as we are moving towards AGI. So if you want, this is the video that OpenAI team is. This was a release video. You can go through this video and then you can check how good this deep research model is. I encourage you, let's say if you want to work on this, if you want to get more deep dive onto these aspects, you can go to these websites and then you can watch more. And then there was a surprise element. Yesterday, as I said, OpenAI team went to Japan, and then this inauguration, whatever the deep research, and then whatever the news that I am talking about was happened yesterday actually, which was in Japan. Yeah. So what happened is, OpenAI CEO, he was interviewed by some guy in Japan for a local media, and first time we are getting an alternative to smartphones actually. So he says that the companies will now embark development towards generating an artificial intelligent terminal which replaces smartphones. Till now, all of us are using Apple phones and then other phones, but in future, instead of smartphones, you will see some generative AI terminals which does the same thing as smartphones, and then it might be an advanced version of smartphones also. So yeah, this is also one news that Sam Altman has given us. Yeah, these are the two aspects that I want to cover before I enter into this today's concept. So yeah, I mean, in last class we on Saturday's class we have discussed about concepts such as OOPS actually, where we talk about class, object, inheritance, polymorphism, and then we also talk about encapsulation, abstraction, all this stuff actually. Right now, I mean, now let's move on to some other advanced concepts, which is called generators, iterators, and decorators. So, what is an iterator? I mean, I'm using this word iterator in my previous classes also. So iterator is nothing but it is an object that allows us to traverse a sequence. So I mean, I'm saying list is also an iterator, right? So where I can, if I'm using for loop, in that for loop, I'm loosely using this term called iterator, where because we are traversing the entire list there. I mean, I'm traversing from first element of the list to nth element of the length of the list, right? So I'm traversing each and every element. That is what a plain sense of what exactly an iterator is. So I mean, so I'm talking about this stuff, but why do we need iterator? I mean, as all of we know, we are having list, tuple, dictionary, all this stuff, right? So where we can store elements in a sequence. Why do we need one more concept called iterator? So yeah, why do we need that is that I'll talk about that the advantages of using these iterators afterwards, but let's now focus on how we can traverse. Let's say if I have a list like this with 10, 20, and 30. 10, 20, 30 are the elements, here I'm declaring that as a list. Now what I am doing is I'm converting this list into an iterator. So here what I'm doing is I'm converting that list into iterator and then I'm storing that in an iter object. Now what I'm doing is now I want to access that iterator. So now you can't use for loops and then now iter object is an object where uh, you can access each value of that iterator by using next method, but not using for loop actually. So as I said, now iterator is having 10, 20, 30. And then let's say if I want to find the first element, how can I do that is by using next. Next of iter object, uh, as I'm in the first step, I'll get 10. So again, if I call next method, I'll get 20. If I call again, I'll get 30. So here, what we are doing is we are storing all the information in iter object, and then we are traversing one by one using next function. And then let's say if you reach to end of the iter object, and then let's say if I access the fourth element in the iterator object, then I'll get an exception. So what is an exception? Exception is different from error. Errors are, I mean, you'll get syntax errors. You'll get some kind of memory errors. So errors are different from exceptions. So what is an exception? Can someone in this class can tell me what exactly an exception is?
It's some abnormal condition that can occur during runtime or when you're executing the program, actually. That's not part of the normal sequence.
Exactly. So let's say if I'm executing some program, So if there is any abnormal situation that might occurs whenever I'm executing the program. So in layman terms, let's say if I'm moving from one place to other place using my car, uh, there might be an tire puncture exception. We never know. I mean, I checked everything. I write a nice plan to move from place A to place B with the help of the transportation. But what happened is uh, this is an abnormal situation. That happened is there was an occurrence of tire puncture. So tire puncture is an abnormal event that occurred whenever there is some flow, whenever there is a task is happening. So whenever we are running the program, what happens is if there might be a case where we might get some abnormal situations. There might be an abnormal condition which halts our program actually. So I mean, in our Python terms, there might be something called divided by zero. So let's if I am dividing a by b, and then user is allowed to enter b value which is greater than zero, right? If it is greater than zero, you will get a coefficient, you will get a reminder. But let's say if he enters zero in runtime, we don't know whether what user is entering for a and b values. But if he enters b value, we might get an error. And then there are something called uh, there are so many exceptions. You might read this concept. Exceptions is also one concept where you can handle that. You can handle that using try and except blocks. In Python, we generally write try block. A try block is a block where whatever code which is vulnerable, we'll place that vulnerable code in our try block, and then we will also have an except block, which is what happens. Let's say if something happens, you need to have that backup thing, right? And you should not terminate the program abnormally. You need to have this smooth, graceful ending for that program, right? So what we will be doing is we will be mm, we will be catching that whatever the vulnerable code is. Let's say if vulnerable code raises any exception, that will be handled with except block. So yeah, here what happens is stop iteration and again exception is raised. This is exception that will be raised when uh, if we if we access the element which is not in the iterator. Let me take an example here, and then I'll talk about the advantages of iterator over list. Okay. Why do we need iterator in first place? And then I'll talk about generator. I'll talk about why do we need generator as we are having iterator. So yeah, here the example is I want to say I'm just having a TV in my house, and then what I want to do here is that I'm having channels. I'm storing that information in a list which is I mean the channels can be anything, CNN, ABC, ESPN, whatever you want, you can write that. So here what I'm doing is whenever we are implementing a iterator concept, I will be having two functions here. One is iter and second one is next. So what iter will do is that iter will return the current object. It will just return the current object, as we have discussed the classes concept extensively on Saturday's class. So you know what exactly an object is, and then what exactly the self is doing. So self will return the current object, and then what next will do is next is just like an increment. So let's say if you are using for loop, so have you wondered how for loop is executed? Let's say, let me share my screen. Tab. It is slow actually. Just give me a moment, guys. So yeah. So let's say if I write this for loop, so for I in L, So I'm taking L to be 1, 2, 3, 4, and I want to print a value. What's happening? What's happening in my first iteration? What's happening in my first iteration? What is my output here? So my output will be in my first iteration. My as L will start from 1. So I'll get I value as 1, and then uh, I'll print 1 as my output, right? And now what happened? What exactly happening is, as we are having list here, automatically the next whatever the see it as I said, list is an iterator. So what's happening here is that the next method is invoked. Whatever the iterate in whatever the concept that now we are talking about iterator concept, right? So the next method is invoked. So from 0th index now I'm going to first index with the help of next method, and then I'm getting 2 actually here. And again, next, at least, I mean, here I'm calling I mean, internally, it is calling next method, and then I'm getting 3 actually. Again, internally, it is calling next method, I'm getting 4. And then now, as we are rising towards end, uh, you'll get an exception. So all these internal implementation for loop, I mean, it is just using this next method actually. So next method is internally, I mean, whatever the for loop that I'm talking now, that internally implements this next method actually. So as I said, here we are having that list, and then what this iter method will do is iter method simply returns the current object, and then next method what we are doing is we are just checking whether at what position we are having, I mean at what is the current state. So if my current index is the last index, I'll just raise the stop iteration exception, and then if it is not, what I will do is uh, I'll just send the current object value. I mean, whatever the index value is, I'll send that index value. So here, whenever you are using iterators concept, you are not using for loop. So as underscore underscore next underscore underscore is a method which is used for this next method will store the information of our current index value. That is the reason why, let's say here, what I'll do is I'll just run this program. So what's happening is initially I'm getting my first value as I'm using next method here. I'm getting first value in the list. So if I run for the second time, if I run for the second time, let me print that. So what we need to get? So here, what happens is that as the next method is storing the index value. So here, if I run for the second time, I'll get CNN. So if I'm running third time, so what's happening is the whatever the last index is, I'm getting that information with the help of iter. So iter is helping us to get the current index value. I mean, to store all, yeah, as the information whatever there. I'm storing that in current object, and then I'm getting all these values actually. So, I mean, what is the use of this iterator over the list? So, actually, we are having list, and then I can use for loop, and then I can iterate using that for loop, right? But why do we need iterator? Why do we need again? Why do I need this class? Why do I need this underscore underscore iter method? And then why do I need underscore underscore next method? As I'm having list is. The main advantage of using this is memory. So let's say if I use list, a list stores it stores it takes more memory actually, but here the efficiency we will be getting efficiency as it is taking a less memory. But the drawback with this iterator is whatever the information is. Let's say if my iter object is 10 GB or 20 GB, I will be storing that entire 20 GB in my local hardware actually. So local, it can be hard disk or it can be uh, whatever the information, whatever the list that I am having, I will be storing that in my local system actually. But let's say if you are dealing with large data, that would not be an inappropriate, that would not be the great solution, right? So to overcome that issue, we would be using something called generators. So generator is just like an iterator, but as I said, in iterators, we will be using something called iter and next method to traverse the elements in the iterator, right? But here, what we will use is we will use something called yield. So what yield does is that instead of storing the entire information into our local environment, I mean local system, instead of storing that entire information in uh, our local disk, I mean, the hard disk, what it does is that it is a lazy loader actually. What exactly mean by lazy loader is instead of storing the entire information, whenever there is requirement, then only it will load the stuff actually. So in real world, whenever you are working with hues and hues images, let's say if I'm having images, if I'm storing my images in S3 bucket. If my images size, the entire folder size is let's say 20 GB, and then you want to process that 20 GB or more than 20 GB, you can't load that entire 20 GB into your GPU or RAM. That I mean, if you load that entire stuff, then the process will be so latency will be high, right? So instead of that, what we will do is we will use the generators concept there, and then we'll use this yield concept so that only one image at a time will be loaded, and then you'll process the whatever the operation that you want to do with respect to that image will be done actually. So iterators, the drawback with iterators is even though it is memory efficient than list, uh, that also stores whatever the data is. What, let's say if it is 20 GB data, all the data will be stored in your in your lam or in your GP, whatever you are using. But if you use generators doesn't store all the values uh, in the current memory. Instead, it generates lazily actually. It generates lazily means whenever you need that, all the operations with respect to that are performed actually. So as I said, let's say here what I'm doing is I'm creating a function which generates the values, which generates and natural numbers. So for this, what we generally do, we will, I mean, we'll be using either for loop or we will be using any of the loop, and then we will generate that, right? So instead of that, so what I will do here is that I will create a method here which is called counter method, where I'll have start index and end index. So start index would be from where I need to start, end would be till how much I need to go. So here, if while start is less than end, what I'll do is I'll start yield start. What it does is that it produces one value at a time. So initially it will produce one, and then after the iteration, again as I'm calling next time, what it does is that it will again, uh, as my start value has been updated here, so I'll generate two in the next call actually. So in my first call, I'll get one as my output. In the second call, I'll get two as an output. So next is a method, as I said. So the what's happening exactly here is that it is yielding, it is generating uh, one value at a time. It is generating values very lazily, and it is also generating on demand actually. So here, as I'm calling for the first time, it is generating one value, and here I'm using here I'm calling next time. That is the reason why it is generating second value. So similarly, you can also use yield for whenever you are loading the hell out of images from your from your whatever the thing that I'm saying about. From your S3 bucket or from your cloud environments. So yeah, to demonstrate this more significantly, what I did is that I have created a file. See here, I have created a large file. What this large file does is that the content in this large file is, as this is 3.34 GB, which is quite big. That is the reason why I'm not able to open this in this editor. But the content is very simple. The content in that file is line 1 line 1, line 2, line 3, and so on. I am storing until 10 power 8. The content doesn't matter, but what matters is the size of the file. So the size of the file here is 3 GB. It is around 3 plus GB. So what I am doing here is now I am using iterator, and then I am also using generator, and then see how I just want to uh, uh, check the time difference. I want to check what is the time, what is the time that happens when I use iterator, and then what times that is elapsed when I use generator. So here simply what I'm doing is uh, here file reader iteration is my class, and then here I'm just loading, see, self dot file, which is I'm opening my file, and then read lines. What read lines will do is that it will read the whatever the file in file operations we discussed this actually. So I'm opening my file in read mode, and then I'm reading one line at a time. So this file uh, file dot read lines, file read dot function will, what it does is that it reads the line one line at a time in that file actually. So for that, here I'm using iter. We all know if you want to implement iterator, we need two functions. One is iterator and second one is next. So what iterator does is that iterator will return the current object, and then in the next function, what we are doing is we are traversing the entire file. We are traversing from the first element in the file to the last element in the file. So as this is 3.3 GB, so I'm before calling this function, what I am doing is uh, I'm from time module. I'm importing the time here, and then I'm time dot time. What it does is that it will start the timer, and then time dot time minus as I'm storing the this is not the start timer. It will give us the exact time at the moment, and then I'll calculate the time now, right now, minus the start time, which will give us uh, the exact time that has taken to read this entire file. So to read the entire 3 GB file, to read all the lines, the time taken for the iterator is 47 seconds. And let's say if I write the same program with the help of yield, which I mean is that with the help of generator, it is just taking 20 seconds. As this is only 3 GB, we might be seeing 30 seconds difference. But let's say if you are working with TVs and TVs, generator works way better than uh, works better than iterator. So yeah, the thing that I want to summarize here is, let's say if you are using iterator, it has objects we have to implement with underscore underscore iter function, and then we need to use the next function to go to the next elements that are present in the iter object. And then, as I said, it remembers all the last accessed items, which means as we are using next function to go to the next value, what it does is that it remembers the current index. And then the main drawback with iterators is that they stores all the information in the memory. Uh, but on the other hand, generators are the way, I mean, it is simplified version of iterator where it is using yield function to yield values on demand. So that is also, it is also called lazy loader. With the help of yield, we are doing that, and automatically this is more efficient whenever we are dealing with large data actually. And yeah, there is one more concept which is called decorators. What decorators does is that so let's say I have implemented a function, and I have implemented a function which is called division function here. What division function will do is division function will divide two numbers. This is what my divide function is doing. But on top of this function, I want to add some more functionality. Like, let's say if user enters, yeah, I mean, here, uh, 2 is numerator and 4 is denominator, right? A and B. If user is entering numerator as small and denominator as big, what I want to do is I want to change this functionality actually. So let's say if numerator is smaller than denominator, I want to swap the values, and then I want to do the division. So here, let's say if I pass 2 comma 4 to this function, I'll get result as 0.5, right? But uh, let's say if you swap the values, and then let's say if you do the division, what will be the output? The output will be 4 by 2, right? So if you swap these values, you'll get 4 2. So to this functionality, I want to add that functionality. So this is what the additionality, right? So let's say if I am checking here, if A is less than B, I'm just swapping. So this is swapping logic. I'm just swapping A and B. So if A is smaller than B, I'm swapping and then I'm just printing the result. So this way we can do that. But the problem is that, let's say if I have some function, I don't want to change that function. See here, I'm having division function which is very small, but I want to I don't want to change the original function, but I want to add some additional feature to that function. How can I do that? Is I can do that with the decorators. So a decorator is nothing but adding extra features to existing function. So here the existing function is just division. So I'm just whatever the values that I'm getting, I'm just dividing that A by B, and then I'm just printing that. But on top of this division, I want to add one more functionality. So the additional feature that I want to add to this division function is, let's say if numerator is smaller than denominator, I want to swap the values, and then I need to do the division. So this is the extra feature that I want to add to this to function. So to do that, what we do is we generally do that using decorators. So what decorators does is that instead of changing the original function here, instead of change here, what I need to do generally is I need to change that function. So instead of without changing that function, I can do that with the help of mm, with the help of decorators concept actually. So let's see here, I have a def function. So here I'm creating one function which is smart underscore dev. Here the smart underscore dev is my wrapper function. So in that wrapper function, I am declaring one. So function inside a function is called inner function, right? So list inside a list is called inner list. So similarly, the as Python is an as I said, as Python is both procedural oriented language and also the object oriented language. So it supports classes and object, and also it supports inner functions actually. So procedure inside a procedure. So here function, I'm saying this as a function, or you can call it as a procedure. So here, here I'm having a function, and inside the function I'm writing one more function. So what I am doing here is that here I will take the core functionality. So the core functionality here is dev. So can you be on mute, guys? What I'm doing is here I'm taking a comma b. So my function is a dev. So I'll utilize this function here. I'll utilize the dev functionality here, and then I'll write my own logic. I'll write whatever the additional feature additional functionality is. I'll write on top of that, and then I will return the thing actually. So let me share my screen and then explain you a bit clearer. So here, what decorator does is that, so the input for decorator is the function. The function is the original function. So you are passing that as an input to decorator. And then what decorator does is that decorator does something extra. Something extra is that here I'm adding that swap logic. Let's say if numerator is greater less than denominator, I'm adding swap logic. So it does extra, and then what is the return type of decorator is it returns the function. It doesn't return any value. Instead, it returns the function. So here also see what what we are doing here is, let's say I'm defining a smart underscore def is my, as I said, this is a wrapper, and see here, I'm take as I said, I want the values A and B, where let's say if A is less than B, I want to swap, and then here what I'm doing is I'm returning the function. So here what is the function? Function in the sense the function is the input. So the input we are passing dev function. So I'll pass A and B as the values. Uh, this does the division value, and then this is extra additional feature, and then finally what we are doing is after performing this entire thing, uh, we are just I mean, as a written value, we are not passing the any values or something like that, but we are forwarding the function. So we are just returning the function. So let me take another other example. So see, generally all the decorators are like this. I mean, I mean, all the decorators are. I mean, whenever we are talking about the classes, also we have seen something called the class methods, static methods. So whenever I'm declaring class methods as static methods, I'm using at the rate classic decorator or at the rate static decorator, right? So here also see, let's say I want to design is a pancake. I want to, I mean, there is a chef where he generally serves pancake. So what this is a normal function, right? So def serve pancake is a normal function. What it is doing is it is generally printing here is pancake. But on top of this pancake, what I need is I want to add some honey. So here what I'll do is I'll add some decorator, where in decorator I will be having an additional functionality. So so in decorator add underscore honey, I will be writing wrapper where I'm here I'm having my own functionality, I mean, the additional feature. So here I'm just adding the honey, and then I'm calling my uh, original serve underscore pancake, right? So that is the method that I want to call. So to summarize this as well, so what decorator does is that decorator is the Python feature. It is a special wrapper that adds extra features to our function actually. So whatever the function is, it will add some extra features with the help of the with the help of the decorators. So yeah, that's about iterator, generator, and then the decorator. There is there is a few more libraries to talk about. One library that I want to talk about is NumPy. Second one is Pandas. Third one is Matplotlib. So what exactly? uh, the NumPy is. So let's say, as I said in last class, whenever we are talking about images, all the images are stored in the form of all the images, or let's say if you take a plain text, how do you convert that plain text into vectors? So how do you convert that is by using embedding techniques, or let's say if I have images, all the images are in the form of pixels, right? It is a matrix of pixels. So if I say I'm storing uh, any image in my system, how does it generally stores? Is it stores in the form of a pixel? So every pixel is a number. So generally, if you are working with any of image data set or any vector data set, you need to do, I mean, a transformer architecture, any modeling is just a mathematical operation, right? So to perform that mathematical operations, NumPy is one library that help us to do all this stuff actually. And NumPy, it generally has something called arrays, and then it has something called matrices, and then it also has something called tensors. So what exactly an array is? An array is just an one-dimensional uh, it is a collection of one-dimensional elements, right? So it is collection of elements in one dimension, which means I do only have length but not breadth. I mean, I do have only one row, not more than one row. So if I have row and column, which means that it is called as uh, matrix. So 1D is an array. Let's say if I have only group of elements, same elements, it is an array. If I have elements in a row and column, I call it as matrix. And let's say if I have row, column, and then width also, which means, let's say if I store any image, how does it store? It store image in RGB, right? So if you are seeing an image, it is the combination of three channels. One channel is R matrix, second channel is G matrix, and third channel is B matrix. So there are three matrices that you are seeing. Here it is not 2D, here it is 3D. So all the 3D matrices are called as tensors. So not only 3D, ND. In ND, let's say there are n-dimensional vectors, which can be three-dimensional, or which can be four-dimensional, or which can be n-dimensional. We call that n-dimensional matrices as tensors. So whenever you are dealing with images in real world, or whenever you are dealing with all the vectors, what we generally do is it is just multiplication, right? So you need to know this library. As I said, this library has so many functionality. This will help us to do all that stuff actually. So here, what is the difference between array and list is a list can store heterogeneous elements. A list I can store one, two, three, and I can store Python, all this stuff, right? So I can 14.0. So a list is collection of heterogeneous elements, whereas if you are storing an array can only store homogeneous elements. Here I am declaring an array. So before this, let's say if you want to use any uh, NumPy related stuff, you need to install that module. So you need to install that library. To install that, you need to use this command pip install NumPy. So this is the command. This command will install that library into our local environment. So after installing that, I need to import this a module, right? So if you don't import that, you'll not get the functions or classes that are available in the NumPy. So here, what I'm doing is here I'm creating an array, one-dimensional array. But how I'm creating is I'm converting a list. I'm taking a list and then I'm converting a list into array here. So here I'm having list 1, 2, 3, 4, 5, and then I'm storing that into. I'm converting that list into array with the help of np.array method. So here I'm also printing what is the type of ARR. Here it is saying that NumPy ND array, and then I'm also printing the shape. Here shape is as it is, as the array is having 5 elements, it is saying shape as 5. And now I want to create here I want to create an array. What I'm doing is here np dot array of uh, I'm taking a list, and then I'm converting that into I'm taking converting that into array actually here. And then once after converting that list into array, now what I'm doing is I'm doing reshaping. So what is meant by reshape is so here the dimension is just what is the dimension of this ARR2 before this? It is just 5 comma, right? 5 comma means there are just 5 elements in that list. There are 5 elements in that array, right? But if I do reshape, here what is the size after uh, reshape is I want to have a one row and I want to have 5 columns. So what I'm doing is here I'm taking that array and then I'm converting that array into matrix actually. Simply see here I'm taking this array, one-dimensional array of elements, and then I'm converting that to 1 comma 5. What it does is that it will convert one whatever the elements into one row with 5 columns, right? So here just let me share my screen. I don't know why this is very slow. I need to restart my system, and I might do that after this class. Yeah, we got it. So as I was mentioning, uh, I'm having a array with 5 elements. Let's say elements are 10, 20, 30, 40, 50. So this is uh, let's assume that as ARR1. And if I find the size of this is 5 comma. That's it. Okay. But I want to convert this into a matrix. So this is my matrix with one row. So 10, 20, 30, 40, and 50. This is one row, but I have 5 columns, right? So now what I am doing here is that I'm converting my one-dimensional array. I'm reshaping in the sense I'm just converting from one thing to other thing, right? Here, so if I find the size of this, I'll get it as 1 comma 5. So yeah, literally what I'm just doing is I'm just converting a array into matrix. See here, what I'm doing is here I am here this is not list. So if you can see here, there are two brackets. So this is a matrix with one row and 5 columns actually. In each row it is having 5 columns, right? So this is if we are having one bracket, then that is list. If you are having two brackets, that means I mean one bracket is two brackets in the sense it is a matrix of one row with 5 columns. So here I'm creating that as an ND array, and then I'm just finding the size of that. Yeah. So if I take this, so here I'm having 1, 2, 3, 4, 5. This is my first row, and this is my second row in the this is my second row in the matrix actually. So how does it look like? So it is looking like this. So this is my first row and this is my second row. So in my first row, I'm having 1, 2, 3, 4, 5. And in second row, I'm having 2, 4, 6, 8, 10. So what is the size of my matrix here? My size of my matrix is how many rows are there? There are two rows. And how many columns are there in each row? So 1, 2, 3, 4, 5. Right? So yeah, this is how you I mean, let's say if you want to represent that in box format, it looks like this, right? 0, 1, 2, 3, sorry, 0, 1. These are rows, and then columns are 0, 1, 2, 3, 4. Okay, so this is ARR. So this is my matrix, and then the size of this is 2 by 5. Right, let's say next thing would be asking. So yeah, there is something called arrange. What arrange will do is arrange. Uh, Arrange is a function just like a range function. It generates the elements actually. So arrange of 0 to 10. What it means is that it will generate from 0 to 9 values. What is 2? 2 is a step count here. So it will generate a 0, 2, 4, 6, and 8. So this is what arrange function is doing, and then I'm doing reshape. So what here reshape is here, whenever I'm reshaping, I want to reshape it as 5 rows and 1 column. So let me share my screen and then show how it is converted. So yeah, so here, so arrange function. So arrange from 0 to 10. Let's assume that I'm having 0 to 10, so 0 to 5. 0 to 5. So that means that it will generate values from 0 to 4 actually, n minus 1. So all these values are generated. So now what I'm doing, I'm converting this I'm reshaping that as this is 1 by 5. I want to convert into 5 by 1. How can I do that is so I see if I have one just one column that is one, right? So just give me a moment here. So I want to convert into 5 by 1. So every row need to have one value. So see if I it does like this, if I do like this, so here I'm having how many rows? I'm having 5 rows, and each row, how many elements are there? I'm having one. So this is one. I'm just having one row with 5 columns, and I am reshaping that from 1 by 5 to 5 by 1. So I'm just converting my 1 by 5 matrix to 5 by 1. So yeah, there is one function called once. What once does is that if I use once with 3 by 4, it will generate a 3 by 4 matrix with all ones in it. So there are 3 rows and 4 columns. So here, see if you can see first row, second row, and third row. Each row is having 4 columns. That is what np dot once does. And then there is something called np.i. You might heard identity matrix in mathematics. So identity matrix means that all the diagonal elements are one. So here I'm passing 3, which means that 3 by 3. So here, so what is my matrix? So my matrix is 3 by 3 with all the diagonal elements with 1. And then see, I just want to, I'm just declaring an array with 2 by 3. And then I just want to check, I just want to print my array. I just want to check the size. I just want to check the data type. I just want to check the size of each item that is uh, present in the array actually. So here, array, if I print an array, the array just simply looks like this. It is just 2 by 3. And what is ARR of shape? Shape function will just give us the what is the shape of that array. And then here ARR of size give us the size of the I mean, size is just nothing but the number of rows into columns. And then data type, what are the data type of each element that is present in the list? Sorry, that is present in the array. So it is int, so it is giving int 64. And then let's say if you are storing something like 3.2 or something like that, you'll get it as float 32 or float 64. So and then items, items type. Let's say what is item size? Size tells us what is the size of each element. So here one in bytes, it is 8 bytes actually. So yeah, all these are they just to get to know what exactly the basic information of array actually. And then let's say if I want to perform operations, like I want to add two array elements. So here I'm declaring array one and array two, and then I want to add element wise. So see, 1 plus 10, I want to get 2 plus 20, 3 plus 30, 4 plus 40, and 5 plus 50. So if I want to do element wise addition, I can just have something like ARR1 plus ARR2. And then if I want to subtract, which means ARR1 minus ARR2, let's say if I want to multiply element wise, I can do star and then I can do divide. So this is what how I can perform element wise operation on arrays. And let's say there are some universal functions like square root function. So if I want to perform a square root of every element that is present in the array, I can use np dot square root of array. So it performs square root on all the elements that is present in the array, and then exponent, and then a sine function, log function. Yeah, all these are uh, some of the functions that are applied on top of every element that is present in an array. Similarly, slicing. So slicing is nothing but axing the elements, right? So just let me scare my screen. So similarly, to access any element in the matrix, you need to give, you need to know what exactly the value of the row value and then column value, as the matrix consists of both the row and column. So you need to give that row and column value. So here, let's say I have my matrix like this with 3 rows and 3 columns. Okay. So generally this will be like this, right? So if I'm having 3 rows, my row index will start from 0. It will go to 2. Similarly for columns. So I'm storing 10, that 20, 40, 30, 60, 50, some values, 100, my plus 25, 64, or minus. You can have any numbers. That doesn't matter. So here, what is a of 0, 0 value? It is 10. A of 2, 2 value is 100. So this is how I can simply access the elements. But I want to do a slicing. What is slicing? So here, let's say I want to uh, slice in the sense that I want to get more than one element. So how can I do that is I can have, see, in slicing, if I want to slice a big matrix, first will be row. I'll have row index and then I'll have column index. Okay, so what would be, let's say if my row is this, I'll have it as one column, and then in the column I'll have it as one column. What happens? Uh, what I'm literally saying here is that I want to get elements from uh, my first row till this end of the number of rows, right? And then what here I'm saying is I want to get the elements of from first column to the last column. So what would be, let's say if it is one one column, what are the elements that I would be getting? So I want to ignore my first 0th row, because I want to start everything from one, right? So I'll ignore the 0th row, and then I also want to ignore my 0th column. So I also want to ignore the 0th column. So here I will ignore the 0th column. So I want to get elements from row one until how many rows are there, and then I want to get the elements from first column till the end of number of columns. So how can I get that is, I can get that like this. I mean, these are the four values that are available. So I need to, so if I print this, I'll get these four values as output actually. So this is what simply here I'm just doing. See here, ARR of 00 is just one. Let's say here I'm taking 3 by 4. See here, I want to get the elements. I want to get the elements from first column, sorry, first row. So I want to eliminate my zeroth row actually, and then I want to get only the elements from my first column to third column. So if I want to get elements from first column to third column, I mean, n minus 1, right? So I need to remove zeroth column, and then I also remove the fourth column because uh, I only want from 1 to 3, right? So 0, 1, 2, 3. So I mean, so I don't want, as I can only traverse till n minus 1, the output would be 6, 7, 10, 11. I think this is clear. So I mean, if you want, I can show that. I don't know. Yes. So see here, I have 3 by 4. So 3 by 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then what I want is I want a column and then one column 3, right? So this is what I want. I want the output of after slicing. So as I said, I want to get values from 1. So 0, 1, 2, 0, 1, 2, 3. So I don't want my first row. I don't want my zeroth row. And then I want these two actually. So I want to get these two rows. I want to fetch these two rows. And in addition to that, what is my column constraint? My column constraint is I don't want zeroth. mm, I don't want my zeroth thing, zeroth column. I want from first column till third column. But as I said, if you are going till third column, I need to only go to n minus 1. So I want to remove that. And if n minus 1 is 3 minus 1, 2. So I want to remove this also. So what is the leftover thing is, so 6, 7, 10, and 11. So this is the output actually. So if you use this, that will be an output. So this is simply mm, simply the slicing is. So I mean, you can play with these two items. That is self-explanatory. And then if I want to modify the elements in the array, as I said, you can change this. A of 0 or A of 0 comma 0 are same. So I'm changing that to 100 actually. And then there are some statistical concepts just like mean, median, mean and standard deviation. So what exactly mean is? Mean is the it is the mid value, right? So what I am generally doing is, let's say I have data like this. So what is mean? So it is 1 plus 2 plus 3 plus 4 plus 5 divided by 5. That is mean. What is standard deviation for this? So standard deviation is, mm, we need to calculate the variance first, and then we need to calculate the standard deviation. So, what variance says is that variance, let's say if I have some mid value, it will calculate how far our data is distributed across the channel actually. So let's say if for this, if mid value, I mean mid value, let's say assume that mid value is somewhere around 3, I'll calculate the variance. If I'm calculating the variance, how can I calculate is xi. Let's say if my point is 1, the variance is xi minus the mean divided by n actually. And then I need to square that. So that is how variance is calculated. So what variance talks about uh, the variability, how far the data points are there from the mean. From the mean, let's say if mean is my midpoint, how they are distributed from the mean. That is what variance talks about. And then if you know the variance, under root of variance is standard deviation actually. So, I mean, it is just, I mean, what my intention here is I just want to show all these functions like mean, standard deviation, and then I want to do scale. This is called scaling or normalization. Normalization is just, I want to subtract data minus, data is 1, 1 minus, for every point I need to calculate 1 minus mean divided by standard deviation, which is scaling actually. Why do we need to scale? That is a different concept, but scaling helps us to get all the values into one proximity actually. So yeah, if there are any outliers in our data, this normalization helps us getting data into under one bag actually. And then there are some more mathematical functions, as I said, mean, median, standard deviation, and variance. You can also define one array and then check what are the values for that. And then you can also do some logical operators like AND. Here I'm just checking whether data is greater than 5 and then data less than 8. I want to fetch the values from 5 to 8. This is how we can include some logical operators and then we can do that as well. So this is all the operations on arrays. Now let's talk about pandas. Pandas is nothing but this is, I mean, as you know, all the information can be stored in Excels or some data can be stored in text files or some can be stored in CSV format. So if we have that data, how do we read that data? How can we perform operations on that? So data frame is generally that actually. So where we can perform operations on the data. I mean, as all the this is the CSV data. So sales underscore data is CSV data. So now what we are doing is we are reading that CSV data and then we are performing some kind of operations on this data actually. So now what we are doing is we are storing the entire CSV data in a data frame, and then uh, we are creating data frame for this data, and then we are performing operations on that data actually. So to do all this stuff, what generally do is we import library which is called pandas. How can I import this? Is pip install pandas. A pip install is a command. You can have any number of, you can install any number of libraries from that. So here I'm importing my pandas, and then now what I'm doing is I am importing my sales underscore data actually. Sales underscore data is my data set. I'm reading that CSV. So pandas is a rich library where it has different functions like sales underscore, I mean, read underscore CSV, read underscore Excel. All you can read all kind of files actually. You can connect to SQLite, you can connect to your databases. You can connect locally, and then you can connect to you can also connect to cloudly also. I'm just checking the data type of each column. I mean each feature that is present in that by using data df dot type, and then there is one function called describe. This is a statistical function where it gives us the information about count, mean. I mean, let's say if you give df dot describe, what it does is that it will take each column and then it will calculate some information about that row actually. So it was about that column. So it will take this column and it will calculate what is mean for that column. It will calculate what is the mean, what is standard deviation, what is minimum value, what is maximum value. It will calculate all these statistical information by it. So that statistical information will give. Whenever you have some data, you need to be like just like a Sherlock Holmes, and then uh, you need to be just like a detective actually, and then you need to find what is there in that. You need to hunt what exactly patterns are. You need to know whether there are any outliers or not. You need to check mean, median. So all this gives us some insights actually. To get that insights, these functions will help. Just like df dot describe, as I said, so describe function will give us all the information, statistical information of that data actually. So now what I'm doing is I'm just creating one list of dictionaries, and then I'm creating data frame for that. So df pd dot data frame. Here I'm passing list of dictionaries, and then I'm converting that list of dictionaries to a data frame. So data frame is just like one data structure where all the information is stored in tables actually. So this is my data frame here. And then df of name will give us all the names that is present in my df. And then there are two functions to access specific elements. One, see here, I want to access 0th row. So I want to access 0th row. So here I can use lock function. And then there is something called iloc function. Iloc function also does the same thing, but the difference between lock and iloc is lock we will be selecting with the help of labels. Labels in the sense something called name, or you can use some column names. You can, with the help of row names or column names, you can access the information that is present here. And then if you want to use the iloc, you need to access based on the index actually. So if I'm using iloc, I need to use this index like 0, 1, 2, 3, 4, 5, 6, and so on. If I'm using lock, I can either use the index, or I can access with the names of the column. Okay, that is the difference between lock and iloc. What I'm doing is I'm just loading that data frame, and then I'm performing operations. Like I just want to find the top five top five rows in my column, and then I just want to know what is the information about that. Are there any outliers in that? So I'm just doing all this stuff. So so let's say if I want to access any specific element, I can do with the help of at function. And then I can also add one column like this, df of salary of all this stuff. I can add column like this, and then I can drop with the help of drop function. So yeah, and then if I want to add age by one, I can do this like just by adding +1 to my function. Yeah, and then yeah, this is very short intro, but what I want to show you here is that NumPy, if we are talking about NumPy, if there are NumPy always talks about arrays, operations on arrays, and the pandas. What we generally do is we load all CSV files into a data structure, just like table data structure, and then you can perform operations on that table-like data structure using pandas. Actually, pandas is a library. There are many number of functions. I just have given you a few functions, but there are a number of functions in Python. You can use that functions also. And to visualize this stuff, there is one module which is called Matplotlib, and there are a few other modules like just like Seaborn. There is one more library which is called Plotly. Uh, yeah, you can use either all those functions actually. But yeah, now what I'm doing is I'm just doing group by. So as I said, if you are having table-like data structure, table-like thing, you can do group by, right? So here I'm doing for this data, I'm doing group by based on product category, and then I want to calculate the total revenue actually. So I can do that by using group by. Group by is a function that is available in Pandas, and then I just want to do sum of all the total revenues based on group actually. And then after doing that, this is what the output is. I want to show that in pictorial representation. So here I'm using plot. Just I want to show that in histograms actually. This is histogram. And then if I want to show the same information with respect to date, this is how it looks like. Here, what I'm doing is I'm just I'm grouping by there we grouped based on product category. Now here I'm grouping based on date actually. So on every date, I want to get I want to group based on date actually. So here I'm storing that in sales trend, and for plot function, I'm passing that date and then total revenue so that I'll get the graph actually. So these are the this all the things that I want to discuss. So all the libraries that I mentioned, like NumPy, Pandas, Matplotlib, or any other libraries, or all these are very much useful for machine learning slash data scientist positions. If you want, you can learn all those stuff. But if you have knowledge on this, that would be great. Because whenever you are working on larger things, these aren't important. But for our course, as I said, as we are moving towards bigger modules, we don't need all these libraries. But if you have knowledge in these libraries, this will definitely help actually. That is the reason why I have included all these libraries in our course. Okay, so that's it for today. I mean, if you have any questions in today's class, you can ask, or else I can see you on tomorrow. In tomorrow's class, I'll start prompt engineering.